which is great. There are some neat things that are there to take you away from the stresses of school, though you're involved in school. We had some homework. Yes? Yeah. We also had, I've noticed that some of you, boy, Ray, you were busy on Schoology. I saw that. You did a whole bunch of those all at once. So Schoology, there's a total of 5. The bonus 2, 3, 4, and 5 quizzes are all open until Friday next week. Okay? So get in there, get it done, and if you don't happen to have your computer's not working from home, use the computers here at school. We have computers in the library you can check onto. We have the Math Science Resource Center down the hall from here. There's an English Social Studies Resource Center as well. They all have computers that you can work on. Get to Schoology, make it work. Okay? It's good points. You could take them up to 3 times. So if you go through the first time and you totally get a bad score, well, jot down the problems, figure it out, and redo it. Work together. You know, some of you have all 5 of them done. Some of you have none of them done. And we've been doing them for quite a while. So they're actually pretty good, and I've been assigning you less amounts of homework than the other CP classes, so you would do that. So please take it upon yourself. What I have planned today is I want to go through the 6 problems I assigned, okay? And then we're going to give you points on finishing the rest of that worksheet. We'll do it all together, okay? So, can I work through the problems? Feeling good? Everyone good? It's Friday, 3-day week. Not bad. We're going to be exhausted next week on the 5-day week. Okay, I know I'm solving it. A couple reasons I know I'm solving it. One, it says, make sure if you have your cell phones out, turn them off. They can be on your desk, please. That's totally fine, but make sure they're off. I know I'm solving it because, one, it says solve probably in the directions. But what else sticks out saying to solve this? Yeah, equal sign. Simple as that. You got an equal sign? It's looking to solve it. Okay? So I don't have a greatest common factor. I don't have an x or a number I can factor out all 3 terms. So what is my magic number, my dreaming number? -8. In order to get a negative, we know what? We have alternating signs. We have positive and negative. And you could do this type of thing. Say, okay, I know I'm going to get down to that, and then I'll solve those. So I'm going to list the factors of 8. So I got 1 and 8, 2 and 4. Which of those would work to give me -2x? 2 and 4, which one has to be negative? 4. Okay, so x squared comes straight down. -8 comes straight down. So you told me I have positive 4x and what? -2x. Okay? If I combine those together, I do indeed. Whoop, 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 whoop. That's a -4 and that's a positive. Whoa, that was good. I checked that. That will give me the -2x. Okay, so we can work this now. What do I have in common between those two I can factor out? X. If I factor an x out of x squared, I have what? If I factor an x out of -4x, I have what left? -4. Notice the sign that how it came. Okay, that's a positive. That works. Okay, what can I factor out of these two? Oh, it's a positive 2 because that's positive. And then that becomes that becomes that. Yes? So what is the answer going to come down here to be? X plus 2 and what? X minus 4. So if we were just to factor this, we get to that. But we want to solve it. So what am I going to do with each of those parentheses? Yeah, I'm going to set each one equal to 0. So I'm going to go x plus 2 equals 0. And that's going to give me x equals -2. And then I have x minus 4 equals 0. And that gives me 4. So I have 2 answers. It was raised to the 2nd power. So we talked about the fundamental theorem of algebra. Whatever your highest exponent is could point to how many solutions you could have. Hey, can I have the same solution multiple times? Could I have an answer of like x plus 4 and x plus 4? Could I have like an answer of x minus 7, x minus 7? Yeah. Yeah. So that definitely could happen. So that's our first problem. Questions there. So we know we're solving it because there's an equal sign. So we factor it, then solve it. Can I clear this?
Yes.
Second problem. Second problem is x squared minus 3x equals 0. So this is not quite as extensive as the last problem. So I have two terms. So first thing I should maybe put in my mind is it could be the difference of two squares. Could be. Does it have to be?
No.
No. It is a subtraction problem. So we do have the difference. And I have x squared, which is a perfect square. But is 3x a perfect square? No. So this is not the difference of two squares. So then we have to look at it and say, okay, do I have a greatest common factor between these? Yeah. I can factor what out of both? X. And what am I left with if I factor an x out? X minus 3. And we're solving it so it's equal to 0. So what's guaranteed to be one of my zeros? One of my solutions. What does this mean? What's x equal to? 0. If I had this be 0, 0 times the quantity is 0, yes? So I know because of that, I know that x is equal to 0. That's one of my solutions. What's my other solution going to be? So x minus 3 equals 0, so x is equal to 3. Good. Two solutions. Pretty simple. So sometimes they might throw a little curve at you, putting two terms, and you might do the go-to of it's got to be the difference of two squares, and all of a sudden it's like it doesn't work, but there's another way to work it. Okay, can I clear?
Yeah, you can.
All right. The third problem I had you work, they actually put a little extra information in there. They put a little extra information in there. What? Can I rewrite this without something? What would I get rid of if I didn't? Yeah. Why is it? Why? Because it's 0. What is 0 times x? 0. So this right here, they just added for you to be extra. So if I didn't have this, how would I write the problem? X squared what? Minus 49 equals 0. Uh-oh, it went down in two terms. Okay? It's a subtraction problem, two terms. It is the difference. Is x squared a perfect square? Yeah, because x squared is x times x. Okay. Yeah. It's probably going to work out too. Cool. Hey, is 49 a perfect square?
Yeah.
Yeah, 7 times 7 is 49. So x squared is a perfect square because x times x. 49 is a perfect square because 7 times 7. Difference of two squares. Is there a sum of two squares that will factor? I can't factor sum of two squares, but difference of two squares I can. Anyone want to take a shot at what this factors down to? X minus 7 and? X plus 7. Perfect. We're still solving this, so what am I going to do with each of my sets of parentheses? So that'll be equal to 0. So x minus 7 equals 0. Add 7 to both sides, so I get 7. X plus 7 equals 0. So x equals negative 7. So positive 7, negative 7. Are those the same answer? No. Positive 7 is a positive number. Negative 7 is a negative number. Okay? I was raised to the second power. I have two solutions. Fundamental theorem of algebra says, hey, that should point to it. It seems to be working. Are we okay so far? You all right? Can I clear this? We good? Here we go. X squared minus 13x. Plus 42 equals 0. Okay? Am I solving it? Why? Huh? Equal sign. All right? What's my magic number going to be? Positive 42. I know in order to get a positive number, I have to multiply positive positive or negative negative. Which one is it and how do we know? How do you know? Yeah, we're minus 13, so I know both my signs are going to be negative. So if I want to do, I can put this like this. I know that's what my factoring is going to go to. All right, so factors of 42. 142, 2 and 21, 3 and 14.
4 and 6.
4 and 6 is 24, but your dyslexia is working well. 6 and 7. It's like, oh, I have dyslexia. I only see numbers backwards. All right. If both answers are supposed to be negative, which solution will work? 6 and 7. This will work. Here we go. X squared comes down. Positive 42 comes down. Yes? All right. So I need to go minus 6x minus 7x. Could I have minus 7x minus 6x? Still going to work. Okay. What do I have in common here? X. If I factor an x out, what do I have left? What does this tell me? Factoring out negative. And what factor am I going to factor out of both of those? 7. If I factor negative 7 out, both those signs change, so that becomes positive x and negative 6. What goes down here? X minus 6 and x minus 7. We're solving it, so I'm going to set each of those equal to 0, correct? So I get x minus 6 equals 0, which gives me what for an answer? 6. I have x minus 7 equals 0. What does that give me for an answer? 7. 6 and 7 are my two solutions. It's raised to the second power. We have two solutions. Fundamental theorem of algebra is saying, hey, take a look at your highest exponent. We feel okay? I have two more left. Are we okay? Feel okay? All right. Let's clear this. Clearing. X squared minus 5x is equal to 0. Hey, am I missing something up here? Am I missing something up here? No. Like, this looks a little different than the other problem, so we don't have that last term. It is subtraction, so maybe we should think difference of two squares. X squared is perfect square. Good. What about 5x? No, it's not the difference of two squares. Where should I go with this problem? Where should I go? There you go. What do I have in common here? Come on. I got to turn all these buttons off. Anyone know how to do that? Hey, how you doing, Cupcake?
Hey, Pop-Tart, what's up?
Pop-Tart, yeah, buddy. Yeah, cool. Nice.
Poodles.
Poodles. It is poodles. All right, what do I have in common here? X. All right, look at that. Can I solve this? What's one of my solutions? X equals 0. I have this. And then I have x minus 5 equals 0. So what's that solution? X equals 5. Two solutions. One of them happens to be 0. That's okay. We feeling okay?
Yeah.
Yeah? Yeah. All right. Last one.
Okay.
Clearing. 2x squared plus 5x equals 12. Does this look a little different? It is solving because there's an equal sign, but does this look different?
Yes.
And why does it look different?
It's a 12 instead of 0.
Yeah, it's a 12 instead of a 0. So what I want to do is I want that 12 to become a 0. So how would I make this become a 0? What would I have to do to this 12 to bring it over to make that 0 over here? Huh? Divide it?
Minus 12.
If I divide everything by 12, 12 over 12 is 1, so that gets me a 1 on that side. Preston, what do you got?
Subtract.
Yeah, watch this. Is this okay? Would that make sense? Okay, do I have a greatest common factor? Is there an x that all three terms have? No. What about 2, 5, and 12? Do they have a number in common other than 1?
No.
Nope. What is my magical number? Negative 24. In order to get a negative, you know I have to have what and what? I need a positive and a negative. Okay, factors 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Which of those would work? One being positive, one being negative. That would give me the 5x. 3 and 8, which one's positive? 8, cool. So, bring this straight down. Bring this straight down. Keep the sign, correct? Which one's going to be positive? 8. And help me out. Cool. All right. 8x minus 3x is 5x. This works. What do I have in common there? 2 and x. If I factor 2x out of that, what do I have left? X plus 4. Love it. And what does that mean? What does that one mean? What does that mean? Minus. So I'm factoring what out? Negative what? Negative 3. That means the signs are changing there and there. So if I factor negative 3 out of that, what do I have left? X plus 4. What's my answer down here? X plus 4 and? 2x minus 3. Set each of those equal to 0. X plus 4 equals 0. So x equals? Negative 4. I subtracted 4 from each side. 2x minus 3 equals 0. So that's going to give me 2x is equal to 3 because I would add 3 to both sides. So what's my answer?
X equals 1.5.
1.5, which is 3 over 2, correct? Okay, so if I divide both sides by 2, I'm going to get x equals 3 over 2. It's okay if you leave it as 1.5. It might be preferred to leave it as 3 over 2. If you made it 1 and 1/2, you're probably also fine. But it's accepted right now to keep it as an improper fraction. Yo.
On my paper, it's negative 5x.
Did I? Was it?
Yeah, it's negative 5x.
Oh,
Oh.
that was supposed to be a negative here? Okay. So, yeah. So, let's just do this, make it simple. On your paper, make that a plus 5x. Sorry about that.
It works with the negative 5.
Well, yeah, what we would have done is we would have had negative 8x and positive 3, and then we would just set opposite signs on our answer. But it would have worked. Cool. Cool, cool, cool. I like it, I like it, I like it. All right. It happens. That's not a big deal. All right.
It shows like hands, like crap. This is crap right here. I'm just gonna erase it. So
All right. So this will be for our notes and what we're working on today, which is great. Is that clear? All right. So yesterday, we started talking about this, and then I got off on a tangent, which often happens. Sorry. I don't remember. All right. We got the area of a rectangle. So, in our minds, guys and girls, we have this rectangle, length times width. I know the area is equal to the length times the width. So, what I want to do is I want to figure out what my length and width are going to be equal to. So, I want to solve this problem. So, in order to find the area, I'm multiplying two things together. Okay, so let's take this right here, and I think we might be able to factor it out. What is my magic number? What's my magic number? Negative 45. In order to get a negative, I need to have what for my signs? Positive and a negative. So factors of 45. 1 and 45, 3 and 15, 4 and 9. No, not 6 and 6. That's 36, but good try.
It's okay.
Okay, let's see. Which of those would have to be positive?
Wait, no.
But you put 4 in line.
Yeah, not 4.
5 and 9, isn't it? 5 and 9. Thank you for keeping me honest. 5 and 9. Good thing we got that. All right, so 5 and 9. So x squared comes down. Negative 45 comes down. Here we go. Which one's positive? Which one's negative? Negative 9x and positive 5x. Could I flip-flop? Could I add positive 5x, negative 9x?
Yes.
Yep. What do I have in common here? Shh, too much talking.
X.
x. I get x minus 9. Still making sense? What do I have in common here? 5. There's a 5 there. So I get x minus 9. What's my answer going to be down here?
X plus 5.
Okay. Now, I want to figure out what the length and the width are going to be on this particular triangle. So I have x plus 5 equals 0. X minus 9 equals 0. So x is equal to negative 5. X is equal to 9. Only one of these is going to work. So if I take either of these and plug it back into the entire problem, if I plug that into the entire problem, I'm going to wind up with 0. But x is equal to what? 9 and negative 5. What would happen if I were to take negative 5 and plug it in there? If I plug negative 5 in there, what do I get? Right here in the green. Negative 5 plus 5 is?
0.
0. Is it going to make sense to have a length or a width of 0 on a rectangle? No. Let's take negative 5 and plug it in here. Negative 5 minus 9 is?
Negative 14.
Negative 14. Does it make sense that I have a negative length or width? No. So what do you think I could tell me about negative 5 as far as this problem goes because of an area of a rectangle? Yeah, this does not work. Okay? So let's think about this. Will 9 work? If I take 9 and plug it in here, what do I get?
Wait, what's...
If I plug 9 in right here, what do I get?
0.
0. Okay? Okay, it's not looking so good for 9 so far. If I plug 9 in here, what do I get?
14.
Ooh. Could I have a side of 14 of a rectangle?
Yeah.
So if I take this 9 and I plug it into there, I'm going to find that one of my sides is 14. 14. Huh. That might be a legitimate way to approach that problem. If I had one of my sides being 14, I like it. So there are sometimes we might come across some nonsense answers because you can't have a negative length. And I'm not going to have a length necessarily of 0 for a rectangle. So that might be something to think about. So I think we've gone far enough on this problem to say, hey, we've established what our length and width can be. We don't know what the area is, but right now I definitely know that one of the sides is 14. We just know that the area is equal to that particular equation. Okay? But one of the sides we could probably say is 14 in this case. Cool? So that's just something to think about. There are times that you might come across an answer that you can't make work because even though it solves mathematically, logically it won't make sense because it's a negative length or a negative width. Does that make sense how I stated that? So I just want us to start thinking about there are times that we might get 2 answers, but one of the answers might not work when solving it, okay? Am I making myself clear how I said that? And that's a newer concept, but that's something that's actually kind of far off. It's actually something that in your Algebra 2 class would be something called an extraneous solution. It's a solution that doesn't work with the problem. Okay? All right, so if we talk about the area of a triangle, actually, you know what? I want to hold off on the area of a triangle. Let's get the homework out, get that page out. And what I want us to do, and you can use this page or you can use your homework to write it out, but does somebody have the homework sitting out right now? Or that worksheet?
Yeah.
Okay, so we did number 1, correct? And does it go 1, 2, 3 across the top? Could somebody tell me what problem number 2 says?
X squared plus 7x equals -10.
Could someone tell me what number 3 says? 2x squared plus x?
Minus 6 equals 0.
Okay, so let's go ahead and try to work these out. Okay, you can work them out on this sheet, front and back, or you can work it out on the actual, if you have that notebook page. It's your choice. So let's call it, let's do it in a minute and 45 seconds, those 2 problems. Ooh. A minute 45, let's try those 2 problems. Did it correctly, please. Double check my work. Did I do it right? Let's see, this step here would have been, and this would have been, yay? X minus 2, X minus 5?
Oh, I got X minus 2, X minus.
I don't know how you did.
Double check, I got it written there. All right, let me try this next problem, see if I can figure this one out. Yes, absolutely. Still going to be the same answer. Any questions up there? Double check where you did. You are more than welcome. If you don't want to jot that down, you're welcome to take a picture of that if you have your phone out. Or jotted it down. It's your choice, okay? Did you get it, Case? Sweet. We got 5, 4, 3, 2, 1, 0.75, 0.5.
I did it.
0.25.
Yeah, no, really.
We good? All right. Hey, can I clear this?
Yeah.
It's gone. All right, clearing. All right, so we did. That was 1, 2, 3 this time. We did number 4 for homework. Yes. What's problem number 5 look like?
2x squared
Minus what?
Equals negative 8x.
2x squared equals negative 8x?
2x squared equals negative 8x.
Oh, okay. Equals negative 8x, like that. What does number 6 say?
6 says 4x.
Like that?
Minus 12.
Minus 12x? Okay. That look right? Did I write them correct? So 2x squared equals negative 8x, 4x to the third plus 6x squared minus 12x equals 0. All right, you have 2 minutes to work these. See if I did it right. There's that first one. What do you think? What do you think? What do you think? Number 6. Looks like.
Wait.
So what did number 6 have? Greatest common factor. Yeah. On the first. No, because I only factored 2x out of 2xx. This was 2xx. I factored a 2x out. Oh, number 6. Oh, right here?
Yeah.
Yes, thank you for. That's why I wanted you guys to check my work because I can't do this. All right. So we have a greatest common factor on this problem. So guys and girls, I'm going to tell you that this and this, I can go ahead and set these equal to each other. So one of my answers is 0. But am I done with the problem? Now, how many solutions should this problem have? 3. Why is that? To the third power. So will it always have 3 solutions? We're just pointing that way, so right now it looks good. So now so one of my solutions right now definitely is x equals 0. So I'm going to take 2x squared plus 3x minus 6. My magic number is this, so I know I have alternating signs. Still with me? And then, let's see, I got 1 and 12, 2 and 6, 3 and 4.
Why?
I'm not getting it to work out.
Right.
Huh. Did I make a mistake? So, what can you tell me about this right here? What can you tell me about what I just circled? 2x squared plus 3x minus 6.
That's the answer.
Yeah, I can't go any further. I happen to know one of the solutions is 0. The other 2 solutions I can't get to because 2x squared plus 3x minus 6 does not factor. Okay? So we do indeed have one solution that we know of. There's 2 others that we haven't figured out how to solve yet, okay? Does that make sense? So I would say if you got to that point, you're perfect. Is that okay? Can I clear this? Anyone need to take a picture of this? 5, 4, 3, 2.
2x equals 0, x equals 0.
So you have this that you definitely know, and then this would be, you could write prime, would work.
That's what I just needed to do.
Right. May I move on? Can I clear? So, guys and girls, we did number 7, but I need to know what number 8 looks like, please. And what does number 9 say? Minus 4x what? Equals 45. Do I have them written correctly? Okay, go ahead and try those. You have 2 minutes. 2 minutes. Here, go. No greatest common factor. What's my magic number? 6. They're going to be positive because of that. So I have positive and positive. Let's see. Factor 6, 1 and 6, 2 and 3. Looks like 2 and 3 will work nicely. Again, I could have flip-flopped them. It's still going to be the same answer. Karen, this is where you got 2, but you remember that right there? Did I do it right? Make sense? That's done. Number 9. Yay? Nay? Jay? Okay. What worksheet is that? Guys and girls, your homework comes from this same worksheet for tonight, okay? For this weekend. So, item 1, Schoology. Okay? Due Friday next week. Okay? But make sure you get it done. Don't wait till next week. Okay? And then I'd like you to do on the worksheet 11A, that's what we've been working on, is 11, 12, 14, 15, 17, 18. Sound good? So get those Schoologies down, and we're just finishing up the rest of that worksheet, okay?